All right, this is our first example problem on page 169. I'll just write it here so you can remember which one it is for now. So this is the one with our pulleys. It says a 1.50 kilogram block rests on a frictionless table. It is attached to a hanging block of mass by a string passing over an ideal pulley mounted to a table's edge. What is the acceleration of the hanging block? Okay, so here we have our table. I'm going to write my little diagram. We have this block. It's probably more like here. We'll call this block M1. And we have a string that's passing over a pulley. Remember, the only way for this string to have force is if this pulley is here. Then we have mass 2. So our question is asking us, what is the acceleration that this block is being pulled downwards? So the first thing that we have to observe is the forces on each block, because we know that the sum of forces is going to equal mass times acceleration. So if we want to find this acceleration, since we know masses, all we have to know is the forces on each block. So what you're going to find here is you're going to find that for mass 2, since it's not resting on a surface, the only forces that are acting on it is the tension and the weight of the block. So if I want to find the sum of the forces for the block number 2, I'm going to say that tension plus weight is equal to mass times acceleration. Well, the only thing that I don't know here is the tension. I do know the weight because I can calculate for it, because we know that it's equal to mg. And we know that mass of the hanging block, because they told us, is 1 kilogram. So we know this is 1 kilogram mass. So we know that the weight is mg, negative mg, because you subtract on both sides, plus ma. So we can solve for the tension using this known values. Well, we want to find the acceleration of the block. And since in order to find the measurement of the block, we must also know what tension this one is pulling on. So the force acting on this one is the normal force and the weight. But as I've told you before, this is going to be the opposite of this when it's on a when it's perpendicular to the surface and the weight is laying flat. If it was on an inclined plane, they wouldn't cancel each other out. But since they're directly opposite of each other, they're going to cancel each other out, so we can act like it doesn't exist. So really, tension is the only force that we really care about. So we'll say this is T2. Tension 1 is just equal to mass times acceleration because of these two forces canceling each other out. So we have tension 1 is equal to ma. Well, since these are connected, what do we know about tension? We know that tension 1 is going to equal tension 2. So then we could say here that tension 1, ma, is equal to tension 2, which is mg plus ma. Well, remember that we can make our coordinate planes anyways. So I can make this coordinate plane like this. And then I could say that my x is here. So this is x and this is y. So that means that this x and this x must be the same. So acceleration 1 must be the same as the acceleration here. So let's do some rearranging and substituting, shall we? Let's put all of our accelerations in the x direction in the same line. So we'll have ma, let's say this is x, and we'll say this is mass 1, minus mass 2 ax is equal to mg. I just switched these over here. This is m2 because I got it from this equation here. So what we can do here, since these both have this same value, we can take this out of the equation. So we can say a to the x multiplied by m1 minus m2. So now it's isolated, equals mg. So now, because I know m1, m2, I know this is also m2. I also know gravity. I can now isolate ax by itself by dividing both sides by this here. So it will equal mg divided by m1 minus m2. And remember that this is m2 because I got it from this equation up here. So then all now I have to do is substitute my values. So m2 is 1 and mine times 9.81. And then m1 is 1.5. So this is 1.00 minus 1.50. And then you just do your values. And you're going to get positive 3.92 meters per second squared. Now, this is also negative because it's gravity. And that's why these are going to cancel. These negatives are going to cancel each other out and give you a positive.